Hello, this is Jason Sage again from Jagus LLC. Find us at jagus.com. I'm doing another video on how to speed up your code, because in the last video I said I was going to show a couple techniques and I only showed one. So if you missed that, you want to check out the other video. It's about the prefetch cache and how to avoid invalidating it all the time by applying a practice. A simple technique to all of your code. If you use it systemically, you get a benefit of speed. Okay, it also covers some stuff about some code flow some techniques I use for that, and how it works for me. So check out that other video too. But on this video, I wanted to discuss very simple binary trees and how you can gain speed when you have a lot of if statements to do, a lot of case statements to check out. This isn't going to help you if you're only just doing a case statement that's got 5 or 6 items, okay? I'm not talking about that. I'm talking about when you have case statements or if statements that are stacked a mile high. How do you make that execute faster? Now, if you think about it, when you have a stack of ifs really thick or a case, the computer tests the first one. If that one's correct, that one happened lightning fast. But if the one it catches is anywhere down in the middle, and the bigger your list is, chances are it's going to be somewhere, there's going to be a lot of instructions that have to happen to work its way down to finally get to where you're at, to meet its goal, to meet that condition that you're looking for. Well, this takes up CPU processes or cycles, and I know we have fast machines, but that's no excuse to write slow, sluggish software. Not at all. If you got a fast machine and you run slow software on it, it's only so good. If you have a fast machine and you run software on it that's like a Corvette, you're going to do that much more with your computer. Don't you want to have software like that? I know you do. Alright, so hold on. We're going to fire up Notepad here. And I just want to give a basic, the most simplest example, because trying to explain code with a page worth of code saying, well, here, learn this, look at this, you see that? Yeah, don't you understand? It's hard to get. It's very hard to understand that way. So what I'm going to do here is just something real simple to try to get the point across. And this will work with case statements as well. So we're going to start with this. Imagine that you had words. We're going to do something with text, okay? Text is often we're checking out people's names, or maybe we're checking out categories, or something like that. Maybe you're making your own scripting language and you have to text for a bunch of commands that people are going to key in. Does the command equal for? Does it equal next? Does it equal go to? Does it equal go sub? Does it equal, then? Does it equal this? Does it equal that? You can actually end up having a mile-high thing of tests that you have to do, and that's what we're trying to see if we can make the computer not have to think so hard about them to accomplish what you're trying to do and do it faster, right? So here we go. Here's a basic one. So I'm assuming that you know how to code a little bit. So I'm expecting that you have some programming knowledge, but I think pretty close to beginners who actually have written a few programs will understand what I'm going to show. Okay, so what I'm going to do is I'm going to do something that's I'm going to try to speed up some stuff that's with the alphabet. We have words coming in. Okay, let's just pretend we have words coming in. It could be apple, it could be pear, it could be dog, it could be cat, it could be murder, it could be assassinate, it could be anything. Okay, so here we go. If left, I'm going to just say a comma 1 equals the letter A. By the way, that's a variable, so that's probably scary, right? We'll say name. Alright, we'll do something like that. If name equals A, then you'd have your, let's see, begin and else. What I'm getting at is instead of having a bunch of stuff that you would just say like if Arnold, well, let's say they're commands. I'm not trying to change up on you. I'm just trying to make this apply with such a short code example. That's why it's a little hard for me to try to word this right. So if I was to say, okay, look, we're looking for programming language commands. Let's say all right, here's a bad example. Okay, here we go. If name equals and then do something, and then here's our bad list. Okay, we have a whole bunch of things like this. Whoops. Let's say we're doing programming languages. So we have if. But imagine we have a ton of them, like there's 100 of them, okay? And done, and finish, And these are all different kinds of things that we'd be testing, right? So, you know, I don't know, let's say if kill, yes, in programming languages there's words like kill. It's a very evil thing. We kill programs, we execute applications. We're very cruel, these programmer people, you know. So right here we have name and then, okay, then it would be like then do something, you know, else do something, do the next if, right? So that's I'm just trying to do shorthand here for what I'm trying to convey. Because what I'm trying to convey is the slow way. If you have a lot of these things, you see, as you get down the list, all right, I know I'm using the same words over and over, but you get the point. I test this. Is that it? No. Is it here? No. Is it here? No. Keep working your way down. Is it here? No. Is it here? No. Is it here? Can you see how monotonous this is? It's terrible. If you have 1,000 things in your list that you have to be doing tests for, I hope you don't have to write 1,000 list of ifs. But if you do, even 500, especially something that's in a loop, by the way, because this gets more important the more it gets repeated. So even if you have like a list that's only like 50 long, you're like, well, I don't have to. It's only 50. Well, if that happens to be in a loop, you better think about this, because otherwise you're just making a whole bunch more computer instructions have to happen than is necessary, and shame on you. Really, you. Shame on you. You can do better than that. All right, so what we're going to do is we're going to get rid of this stuff here. That's the bad way, and we're going to show a way to at least break it down a little bit, okay? If A, then now you can do your little if commands. If name for the letter A commands, right? If name equals Alfred, I don't know, these are programming things. How about? That looks almost like a command. You know, then something. Now we do the same thing down here. I'm giving the example out here. Hang on. I think I'm getting that point across. I'm trying to get this point across because I think it's a good one. Okay, so here we go. Now, what we've done here, I can't think of another word for B that would be with coding. Excuse me. I cannot do this. What the heck? Break. Yeah, there we go. Haha. All right. So now what we're doing is we actually made the we're beginning to make this first pass of coding based on just the first letter. And this is just one example of a technique. I'm hoping you can come up with other ways to apply what I'm showing here. Because what's happening is now instead of going through, let's say, 100 different commands, I do one command to I do one if statement that just checks for the letter A. Well, that brings the number of commands down to a very small number, doesn't it? Because they're not all going to be beginning with the letter A. It's going to, just by doing that one test, instead of going through 500 commands, I might have just forced our logic to only have to go through maybe 20 if statements. And then with the letter B, it only has the B ones. And you can actually nest this and take this technique further. If you understand what I'm saying here, you can take this and nest it even deeper if you have that much stuff to deal with. Okay? Now, this works with case statements as well. Okay? You could. Now, most case statements don't allow you to have this complicated of an if part on it. All right? But you could still do things like, we'll show an if statement version of it, where you, a case statement, I'm sorry, where you actually would make a variable first. That would, we'll call that just that variable letter equals left string, you know, left whatever, left name, comma 1, okay? So that would be our A, and then we could do case, letter, of, and then we could do things like this. Okay, so that's the end of our case. That's what I'm trying to say. Then in here, you get right back to this. Which could be case statements too, if you have a way to do that and it's appropriate. Okay? Because that's still accomplishing the same task. Instead of going through, like I said, 100 or 500 commands, I do one check that eliminates more than half of the stuff I got to look for. Okay? And this really can speed up your code. Now, I got to tell you, when I'm writing a program, I don't bother with this right out the gate. I don't. This is an optimization technique I use, and it's fast as heck. In some cases, it can make your code look very neat. In some cases, it doesn't, especially when you get into the nested version of it. It can actually look pretty ugly. That's why I use it for an optimization technique and not so much when I'm in the trenches working on it every day. But like when I'm like, okay, it's time to tune this puppy up, then I'll sit there and make myself my binary trees. And the speed that you get from it is phenomenal. I know it's measurable. I know it's significant. It's not rocket science. If I can take 1,000 or 1,000 tests and turn it down into 100 tests, that's a benefit right there. And if it's in a loop, that's exponentially better, isn't it? So that's the end of my video. I wanted to share this with you, and I hope you understand how you can use these binary trees to make your code run like a Corvette. Well, I'm Jason Sage from Jagus LLC. You have a great day.